Welcome everyone. Today we will learn the drawing of cross-section and interpretation of geological history of this particular map. So this XY is our section line along which we have to draw the cross-section, that is we have to slice this area vertically and see that how these rocks are present in subsurface conditions. The map, geological map, in fact, is a bird eye view map where the traces are plotted at different positions. We plot them as they are occurring in the field. And now, for information of relief, the contour lines are drawn. So this is a bird eye view. The different colors are representing different lithologies in the area, and the contour lines are representing the elevation of the area. The top of the map is north. The map scale is 1 inch is equal to 1000 feet. So before drawing the cross section, let's try to understand the map. The first point we start is a relief of the area. So we can see here that the minimum contour value is 100 feet and the maximum contour value over here is 1000 feet. So that indicates that this area lies above the mean sea level, and the minimum relief is more than 0 feet and less than 100 feet. And the maximum relief is more than 1000 feet but less than 1100 feet, because we are not getting the 1100 value contour. And as we can see that here are the notches and the elevation of the area is increasing over here. So there are different hills which are separated by some narrow valleys like this. So here is a hill, the height is increasing in this direction. Here the height is increasing in this direction, and there is a valley, there is one more valley. So these hills are separate. There must be small drainages above the hill which have carved the hill. So this was about the relief. Now what are the structures that are present in this particular area? So now we can see that this is bed number D, and in both the direction of bed number D we have bed number C, then we have bed number B, then we have bed number A. So this type of pattern is known as cyclic pattern, and it is represented by folds in any area. So either this line in between bed D is representing imaginary line, axis of an anticline or syncline, we will know later on, but we are clear that this one is a fold. What type of fold? That will be determined by drawing the strike lines at both the limbs. Then we can see one more thing, that these widths A, B, C, D, they are affected and they are shifted. If we see this line, along this line the area has been divided into two blocks, so they have shifted in such a manner so that they are giving a cyclic type of repetition when we are comparing both the blocks. So this line represents a vertical fault, because this is a straight, as we have learned earlier. If any structure is straight, then what is going to happen, or vertical, what is going to happen? It is going to give us a straight trace in a bird eye view. Then we can see one more thing, that these beds A, B, C, D, they are being truncated against a trace. All the beds A, bed B, bed C and bed D, they are abruptly getting truncated against a trace. This truncation occurs only when we have presence of unconformity, because the unconformable surface is the one which is the surface of erosion and non-deposition. So when the A, B, C, D must have been formed and they are folded, and after the folding when they got uplifted, the area must have been undergone the process of erosion and non-deposition, or there was an event where the deposition was very feeble or erosion was dominant because the area was uplifted. So at that time this surface of unconformity got developed. And then when the area subsided again over this unconformable surface, there was deposition of bed R unconformably, followed by the deposition of bed S. As we can see that older sequence over here, because we have unconformity, so we have got two sequences, older sequence which are more deformed, and younger sequence consists of R and S beds which are less deformed. So this we can see that R and S, they are not parallel to the contour lines. It means that R and S are also dipping. Means after the deposition, when the area was uplifting back again, it was tilted a bit as well. Then we can interpret the events or order of superposition. So as we can see that to interpret that event, we will have to come to know about the ages of the beds. That is the only means we can interpret the relative history, or simply by plotting the strike lines we will be coming to know what are the ages of the bed. So I have chosen this particular trace in order to determine the limb dips of this side. So we need another strike line as well, that is of HB. So here is a point, at one point it is intersected here. So we need to draw it in fact parallel to earlier strike line. So this value is 200 and this is 300. It means this limb is dipping in this direction. This is axis of a fold. Now we need to determine the limb dip in this direction as well. So here this is one strike. The value of this strike is 200 again. And here is 300. So here the beds are dipping in this direction. It means if we take this axis, the beds are dipping towards each other. So if we draw a fold like this, so this is a fold in which we can see that this is syncline or syncline, the beds are dipping towards each other at the axis of syncline, and an anticline they dip away from each other. So this is axis of a syncline, and we know that at the axis of syncline or the core of syncline we have younger beds. So if this is bed number 1, this will be 2, this is 3, this will be 4. This is the youngest bed. So at the core of a syncline we have youngest bed. It means this would be the youngest. So if we have 4 beds, this will be bed number 4. So here the bed D is in fact youngest bed of older sequence, and it is bed number 4. Then C will be obviously bed number 3, and B will be bed number 2. So mark at all the positions, and bed number A is in fact bed number 1. So A is oldest bed. Right. So we have interpreted the ages of, or relative ages of older sequence. So bed A is oldest and bed D is youngest. So now we can interpret that bed A is oldest, so it must have been deposited unconformably over unknown basement followed by conformable deposition of bed 2, 3 and 4, then the area must have been put under ductile compression. So because of plastic deformation, the fold must have been developed and this fold is centerline. Then the area got uplifted and it was exposed for the erosion. So after the erosion, this unconformable surface developed, then the area again subsided. So there was deposition of bed R and S of the younger sequence. So this is the first bed of younger sequence and this is second bed of younger sequence. So R and S have replaced their first and second beds. So first and second bed of younger sequence. Then the younger sequence was deposited and after that the area was uplifted, tilted and faulted simultaneously, because we can see this fault is affecting all the surfaces, the older beds as well as younger beds. So it means this fault is the youngest feature in our area, this vertical fault. So this is how we can interpret. Now let's draw this map. So in order to draw this map, first we will have to determine the dip of the different limbs as well as the dip of younger sequence. So here we can determine on the section line direction that these dips, we can go with traditional method. Either we can use our dividers to measure the HE, so either we can measure HE and plot somewhere this HE, and then we can plot CI over HE. So that so 0.1 each over HE. And now join these 2 points. So that is going to give us the limb dips in this direction. So this is 10, 15, 16, 17 degree. So these limbs, these traces are dipping towards from X to Y with an amount of 17 degree. Have to remember. And then let's see this one. So again we need to measure this length. This is HE. You have to plot this HE as well. And after this HE, we will have to plot pointing and 1 inch, that is our CI. Obviously this HE is a bit larger, so the limbs in this direction must be dipping with some smaller angle. So here we can measure this angle as well. So this is roughly 13. So these limbs are dipping with an amount of 13 degree in this direction from Y to X, and these limbs are dipping with an angle of 17 degree from X to Y. Now the dip of younger sequence that we can determine by determining the dip of unconformity. So this is 700. We can take any 2 points. So here is 800 over here and 800 over here. So we have to take such as so that we can get these 2 points over our section line. So rather than choosing this one because it is going to go away from the section line, I am taking this 700 point. So if we join these 2 points, we will get one straight line for younger sequence. The value of that will be 700 because this straight line is obtained by value of 700 contour. Now we can take another one less or more than 700, that is 600 or 800, but it should come at our section line. So, and this will be parallel as well. So here we are drawing it 600. It is intersecting at this point and this point. So parallel to this one, we have got another straight line for younger sequence, that is 600 value. So younger sequence is dipping in direction from x to y, that is towards east. Now let's determine that what is the amount. So in order to determine the amount, we need to measure this distance, that is equals to HE in this direction. So here we can measure it and draw it. So once we have drawn this HE, now we can draw 0.1 inch over HE to know the CI. So this 0.1 is in fact CI. Now if we join these 2 points of triangle, so this is a right angle triangle in which this line is representing CI and this is representing HE. So this will be obviously theta for in the sequence. Let's measure this theta. So this theta is roughly 6 degree, 5 to 6 degree. So let's take it. Yes, it is around 5 degree. So younger sequence is dipping with an amount of 5 degree. This one is dipping with an amount of 17 degree, and these two, they are dipping with an amount of 13 degree. So now we have determined the dip amounts and dip direction for different beds and different sequences. Now we can plot this particular map. So in order to plot this map, either we can make use of some strips, or we can in fact fold this map. So let's fold this map to save the time. So here is our xy point. We have folded this map along xy line. Now mark the x and y points. So this will be our baseline, x and y point. Then we will plot the contour values in order to draw the profile. So here are different contours. The value of this contour is 900. The value of this contour is 800. I am writing only one digit: 7, 600, 500, 400, and we are not getting any of the contour. This is 300. So here this point will lie between 400 and 300. Then we can also draw the position of beds. So here I have one bed, and here we have another bed. This is unconformity plane, so I am writing U. This is one more bed. So in order to know, this is a fault position, so I am writing F over here. This is our another bed. Writing P over here. Now we can join these lines. So here is our baseline, join the baseline. Now plot the contour values to represent the height and to draw the profile. So our contours are varying from 100 to 1000, so up to 1100 it will be fine. So here is our 1000, here is 900, 800, 700, 600, 500, 400, 300, 200, 100, and this is 0. Then in this direction as well, point 1, point 2, point 3, point 4, point 5, point 6, point 7, point 8, point 9. So here we have 0, we have 200, we have 400. I am writing only one digit. This is 4 for 400, 6 for 600, 8 for 800, 1000. So here is 100, 200, 300, this is 400, this is 5, this one is 600, this is 7, this is 800, this is 9, this is 1000. And in this direction as well, this is 0, this is 100, this is 200, this is 300, 4, this is 500, 6, this is 700, 8, this is 900, this is 1000. So now let's plot these heights, and after plotting these heights we will get the profile. So here is 900. Let's project this point. It's 9, this one is 8, this is 700, this is 600, this is 500, this is 400, and after 4 we do not have any of the contour, so the trend is towards 300, and here this is 900 and trend is towards 1000. So if we join these points from a smooth hand, then we are going to get the profile. So let's join it between 1000 and 900. So here we have this point should fall in between 1000 and 900 rather than exactly 1000. We'll have to make it somewhat lower. So this is our profile, like you can see. Then once we have drawn the profile, now we are supposed to draw the fault and the unconformity first. So this is our fault. Fault is vertical because this is represented by a straight line. So let's draw the fault first. This feature is vertical. Below we have to draw, we can draw it by dissected line and above. So this is our fault. Now let's draw the unconformity. So we know that the younger sequence is dipping with an amount of 5 degree and the direction is from x to y. So we can plot a 5 degree angle taking any point here. So here is 5 degree. This is the dip angle for younger sequence. So unconformity is dipping the same amount, this 5 degree. Now we can project these points above onto the profile. So this is unconformity, it will come here. And after the unconformity, let's see where is the younger bed. So here is unconformity and here is our younger bed sequence. I'm writing y that. So we can project this bed as well. They will be following the similar trend because they belong to younger sequence. So here is the one younger sequence bed. Let's plot it. This is our unconformity, like now younger bed. So this is our plane of unconformity. We have to draw it by zigzag line. Now we also need to mark the unconformity in map as well. So we'll mark it by zigzag line. This is plane of unconformity, which is separating the two sequences, that is younger and older. The 4 folded bed of older sequence from 4 simple dipping beds of younger sequence. Earlier I did not mark because lots of marking will hide another features and it will be tough to measure the angles. So here we have marked the unconformity at this place as well. Now we have drawn the younger sequence and we are supposed to draw the older sequence. Before that we can also determine the down through direction because this is a vertical fault, so if the younger beds come in contact with the older beds, so that side is down throw, it means this side of the map is representing the down throw side. Let's plot these beds. So now we can see that only this bed is coming over here. In order to draw the another bed, we will have to stretch them along the direction of their strike. So this is strike direction. If we need to draw this bed, we will have to stretch it in this direction only. So we will get the trace of this bed over here, and we will get the trace of this bed. Right. So now we have got all the traces. We will not get the older bed. So by determining the thickness of this bed, we can get this particular bed. So in order to determine the thickness in this direction, what we can do, we can plot different strike lines. Like if this is a strike line, the value of this strike line is 300. Another strike line here is 400. Now taking the same HE, we'll plot the strike lines till the point we reach up to the another trace of the bed. So here we have reached to another trace. So this is 3, this is 400, this will be 500, this will be 600, and this will be 700, and this is intersected by 600 value, right? So because this is 700 intersected by 600 only, 500, so here we can see this is our 300, this will be 400, of course this one will be 500, this will be 600, this will be 700, this will be 800, and it is intersecting only 500, so it means there is difference of 300, meaning the thickness of bed B is 300. So now we have the thickness of bed number B, and by plotting the thickness of bed number B, we will get the one trace of older bed, and that will solve our problem. Now let's plot the position of these beds, which we have got by extrapolating them in the strike direction. So here is our older bed, and here we have one more older bed. Right. We'll have to project these onto the unconformity position. Here is one, and here is another. Another bed we are getting this position. Right, one bed we are getting this position, and the beds in this block, the different limbs of this block, in fact this one, they are dipping in direction from X to Y, and dip amount is 17 degrees. So let's plot this amount. Let's plot the value of 17 degree. (15, 16, 17 degree). Which join these 2 points, that will be 17 degree. And the beds of another limb, they are dipping 13 degree in opposite direction. So let's plot that angle as well. 13 degree. 13. Degree. Now let's plot the beds of this direction like this. So we have to make it parallel this angle. Now we have got one bed over here, so they are going like this in the ground. Another older bed you can see is here, so we can plot this bed as well parallel to this line only. Then we are getting some more traces of the beds, one over here. We got one bed here, one bed here. We are not getting the older bed. Well, we can get that by taking the amount of 300. So 0.3 inches vertically will represent 300. We can measure this. One, two, three. So we draw a parallel line, taking this amount as so this will give us the bed A. So now we have got bed D, we have got C, we have got B, and we have also got bed A by drawing the thickness of bed B. Now these beds are dipping in this direction with an amount of 13 degrees. So let's plot them as well. So here is the reference angle and the bed is over here. So parallel to this we will have to draw. So we can plot like this. Then we have bed C. Here where we have one more bed. So that also will be parallel to this line. This is B only. So how much is the shift or throw that we can measure it, because this is again the trace of this is the trace of youngest bed A, this is the lower trace of bed B, and here we have the trace of bed D. So we need to plot, this is lower trace of bed B, but if we want to plot the bed B, we need to have a thickness. This is oldest bed, that is bed A, then here is a B. We need to plot bed B, we'll have to take the thickness of 300 and we can plot B. Here we have a lower trace of bed B, so this much is the throw amount. Right. So now we can extrapolate these values, because these beds are folded, so they must not be going like this over here. We'll have to make them folded. So this is the point, they are folded. Then bed C, we can determine the thickness of bed C. This is roughly. So let's determine the thickness first, then we will plot in that direction. So here is 200, here is 300, and next one is plot will be of 400, and it is being plotted at 200. So the thickness of the bed C will be 200 feet. So if we want to draw the thickness of bed B we can draw equals to 200. So by taking the point here of 0.2 inches, we can draw our bed C. Obviously that is not occurring at profile, but the bed is present below the profile, that is at subsurface conditions. So now we can join them and make a folded bed. We know the thickness of bed B is 300, so we take 0.3 inches from this point. Vertical thickness is 0.3 inch, 0.2 and 0.3. So if we plot one line parallel to this, we'll get this bed as well. So let's remove another features and draw the beds only. Here we can join them. So now we have got all the beds. Now we can remove this baseline and see that how beds are looking like onto the ground. So here we have bed A and here we have bed A. So this is the amount of throw. Let's try to know that how much is the amount of throw. So that can be known by drawing the strike lines in both the blocks. So this is having value 300, this is 400. If we draw one more value like this is going to intersect it over here, the same trace. This is intersected by 200 and this is by 600. So roughly we have, or we can say that this is over here. So this is by 300, this is 500. So we can say that roughly there is a throw of 200 and that we can see that there is a difference of 0.2 inches. So this block is down thrown block as we have plotted earlier. This is down thrown and this is up thrown block. Now let's darken it with the help of some pen, etc. So here is our fault. It is going in ground like this. Above it is not exposed. This is our unconformity plane. This is our younger bed, youngest sequence. And this is profile. Is supposed to be drawn smoothly from this point to unconformity. Then the trace is going like this. Above the trace, all the features are now eroded, but this must have been present in the past. Unconformity is always drawn by zigzag line. So we are going to draw it by the chair line. And we can draw these beds. So here we have plotted these different beds. We can extrapolate this fault in order to see that how the throw is there, and we can extrapolate this bed. That we can do by dissected line. Even we can draw these beds onto the above as well, but because these are eroded, we are not drawing it. So if you need to draw, you can take 0.3 inch and draw this bed over here, bed number 3. This is bed A, this will be bed B, this is bed B, this is C, this is B, and this is bed A. So if you need to draw the bed B, what we need to do, we can measure this angle, this length over here, how they must have been there in past, this length, then taking this length we can draw it like this. So if you draw line parallel to this one, we'll draw it by pencil because they are now eroded. Then this is how the bed must have been in the past. So this must have been bed B. Then for bed C, we can take this thickness and draw it here, how they have been in the past. After the faulting, the area has been exposed and it has been eroded. So this is our bed C. For bed D, here is bed D. So this is the throw amount. This is how the area is looking like. Now we can draw the down throw direction of the fault. This is down throw and this is up throw, because this block is going up and this block is going down. So this is our fault, this is unconformity. Now we can fill the symbol and our map is complete. So let's fill the symbols. Let's see how symbols are there in our map. So bed D is represented by yellow color symbol. We will fill yellow color wherever the bed D is present in our section. So here this one is bed D. Then C is represented by red color. This is our bed C. Then if we see B, B is represented by the green color one. So here is 5. screen color. We have bed. And here we have exposure of bed B in this block as well. The bed must have been there in the past, but it is now eroded, so we are not going to give any color to it. Now bed A is represented by blue color. So let's take this color and color down this. Here is all A. We don't know the base of the oldest bed, so it is an unconformable base. In zigzag line over here. So now let's color the younger sequence. So this is in fact the oldest bed of younger sequence is in orange color. So this is the color. Instead of the unconformity, it is exposed for this much of distance into our section line. Very thin veneer of older bed of younger sequence is present just below the profile that is exposed from here to here. And then we have bed S of younger sequence. So this is the youngest bed. It is present from this point to this point only. So this is how our cross section is going to look like. So we can write here that this is our geological cross section along x. So in fact this point is x and this point is y. So we write it at baseline, this is 0 feet, and here it is 0. We write it always on baseline, but the truth is that this is x and this is y. If we start walking from x to y, we have height variations from this point to this point. So first we are going, the height is decreasing from this point to this point. First we are getting the bed number S from this point to this point, as we can correlate over here. From here to here we are getting bed S. Then we are getting R from here to here. So from here to here we are getting R. Then we are getting bed D. Yes, obviously we are getting bed D. This is bed D. Then C. Then after that we are getting bed number 2, that is bed number B. So B over here to here, and then bed A from here to here. Now below the subsurface these beds are present of older sequence. So below we can see the bed C, bed B, bed A, they are all present and they are not coming at profile, but they are there in the subsurface. Now let's interpret the geological history of this area. So as we can see, the bed number A was deposited unconformably over a known basement, followed by conformable deposition of bed B, C and D. This deposition must have been in such a way that there would have been horizontal beds following the principle of initial horizontality. Then the area must have been subsided to greater depth where they can go under ductile compression. So there the folds have been formed and this area was folded, in which the D came in core and A was outside because it was oldest bed. So this is in fact a syncline, core of syncline. Mark it. We have already marked it, but in order to visibility we are going to mark it some colored pen. Now we have to mark this core of syncline as well, so that we can do by marking the symbol onto the core. This line should be straight, clear. Remove it once and draw it with the help of a scale. So here is our fold, and this is center. Right. When the area was put under ductile compression and folding took place, and the area was uplifted and it was exposed for erosion. So this line was, at that time, was horizontal, and then the bed number R and S was deposited. R was deposited unconformably over this particular line. This exposed trace or exposed surface of unconformity, then S was deposited conformably. Then the area was again subsided, or in fact uplifted, and that tilted with an amount of 5 degree clockwise direction, and it was all exposed so that erosion gave rise to this pattern like this onto the surface. And by analyzing the structural data, we can come to know that how these beds are present into the subsurface conditions. So this is our map, and this is profile for this map. Now the only thing which remains to explain is order of superposition. So order of superposition is more like this: the bed D, then bed C, then bed B, then bed A. This is D, and this is A, this is B, this is C, and this is D. This is again unconformable, and here we have one unconformity. Then we have bed number first and bed number second, that is R and S, and these are folded beds. So we are not supposed to draw it folded, we have to draw only the order of superposition. So this is how this bed must have been plotted. So we always discuss the geological history and another points like topography, geological history, order of superposition. So we take 4 major points in order to discuss any of the map. So in this map as well, we are going to do the same thing. The first thing is our topography. So we can see the map. The relief is varying from 100 feet to 1000 feet. So minimum relief is more than 0 feet but less than 100 feet, and maximum relief is more than 1000 feet but less than 1100 feet. Then the structures. So what are the structures? There is one unconformity, this is angular in nature. This separates 2 sequences. Boulder consists of 4 folded beds. Fold is in fact syncline, so we have one syncline. And then we have younger sequence, that is 2 beds which are dipping in nature, or 2 simple dipping beds. So these are structures. We have 2 sequences: older sequence, we have younger sequence, the folded older sequence, and simply dipping younger sequence, and one angular unconformity, and we have also presence of a fault. So these are, and fault is vertical in nature, and this is post unconformity fault because this is affecting the unconformity. Then order of superposition. So order to draw the order of superposition, we take the initial undeformed position. So that A, B, C, and D. This upper surface of D is unconformable surface. This is unconformity. Then bed R and bed S over here. The fault is present, which is affecting all the sequence, so we are going to write F over here. The fold is also present, so we only mention that these beds are folded. Right. Then geological history. We have already explained, let's revise it once. So that A was deposited unconformably over a known basement, followed by conformable deposition of bed B, C and bed D, and the area was put under ductile compression, so folding took place, and then the area was uplifted and it was exposed for erosion, and after that the area was subsided again. The bed R was deposited over unconformable basement, then S was deposited conformably over all, then the area again uplifted, tilted by rotating 5 degree in clockwise direction, and then erosion took place. So this lead to present day landscape. Thank you everyone. So today we have learned a map containing number of structures like folds, faults, unconformity, and together with simple dipping beds. So in next classes we will be doing some more complex maps containing even igneous structures, etc. Thank you.